Hello, students and parents. Mr. White here checking in with our practice test for Chapter 9. We're doing a walkthrough. Let me just tell you, we're going to be doing a lot of unit analysis. We've covered this so much in class. Basically, the entire chapter has just been on this fundamental concept. So we're in fundamentals of math, and it really is fundamental. As I've shared, you're going to keep using this through the rest of your math studies, as well as it'll come into your science. And we've heard from future teachers that you will have that it's really, really important that you learn this. So my hope is that through everything we've done so far in this chapter and throughout this class, this will be one of those things you really pick up and start to master, because right now we're at such a fun level. I know you might not think it's that fun, but it really is, because when you know the method to use, you can suddenly unlock all these answers that if I saw this and you said, Mr. White, how many ounces are in 3.25 pounds? I'd say, I don't know. I don't know how to do that, but give me a piece of paper and unit analysis, and I will figure out and let you know how many ounces are in 3.25 pounds. So it's going to be really important that we use unit analysis for everything. And that's what I'm expecting when we come to the test. It's not that you say, Mr. White, I don't know how to do this. Because how could you not when we've gone through this the entire class for the last like 3 to 4 weeks? Not saying that it means you have to be super confident in how to do it, because this is maybe new for some of us, and math doesn't always come super quick to a lot of us. I understand that myself as well with certain concepts. I'm like, what? But the more I practice it, that's the key point there. The more you practice it, the more you will get into it, become more comfortable with it. And as I shared in class, my expectation is that you know how to set things up in unit analysis. It doesn't mean your math is going to be correct 100% of the time, but do you understand the main concept? So that's what we're getting into. These first ones, though, are more about weights within the different systems. So one side of a vegetable garden, the best way is go through process of elimination. Half of a foot, 6 inches, about this much. Is that going to be the side of a vegetable garden? No. 30 feet, maybe, but 300 feet, oh man, 300 feet sounds way too big. So no, not 300 feet. So that would be 30 feet. Weight of a large dog. Some of you asked in the class when we were going through this, like, well, how big is the dog? Well, Teddy, my little dog, is around 12 to 15 pounds. He's a small dog. He's a Chihuahua Pomeranian mix. So 12 pounds, no, that's a small dog. Even if you don't have a dog, 12 pounds is not too heavy. How about 75? Maybe, but let's look at the next one. 750 pounds. 750 pounds would be huge. I told someone in class, and this is not even to be offensive, but when we're looking at weight of people, someone who is like considered extremely obese could be around 400 pounds, like 500 pounds. I don't even know 500, but at least 400 would be considered obese or, extremely obese. So would a dog be more than that? Like, think of one of the biggest humans you can think of, and they're nowhere near that. So no, that is, I don't know, not to be offensive as I mentioned, but just sort of how I think of it when I'm thinking through like dogs. I've held lots of small dogs. I've picked up big dogs too. I've walked big dogs, and they are probably around 75 pounds, even without truly knowing. So this one, capacity of a sports drink bottle, milliliters. Ooh, that would be tricky because I don't actually know that either. But let's think through it. 75 liters, 2-liter soda, those big giant bottles. So 75 liters, that would be way too much in a sports drink. And then 7 milliliters. We know milli means 1,000. So 7. No. Like that would just be like super, super small. So that would not be either. So therefore, we would choose A. That would be the most reasonable answer. So that's kind of how you work through these, is you don't necessarily have to know, like, I don't drink sports drink bottles, and Mr. White, and I would say neither do I. So don't worry. But let's go through process of elimination and use context of what we know. And our homework has gone through this the entire chapter. All right, next, we're jumping right in, customary, and then we'll do metric, but we're using unit analysis. So what does that mean? We start with what we're given, 6 yards. And then we always set it up like this. We've done that, and we can do that for every one of these. So if it makes it easier for you, and You know, I think the nice thing with some of these tricks is there's a lot of psychological help that you can bring yourself as you're doing these. So like, say I finish this and I'm like, wow, Mr. White, you're already done like almost half the page. And these are like halfway done. Next thing I can do to really help myself is when we only have one to go to, so we're going yards to feet, pounds to ounces, gallons to quarts, fluid ounces to cups, then we know we need to cancel out, get rid of the yards because we don't want yards. We want to figure out feet. In order to cancel out that, it needs to go at the bottom because this is the same thing as saying 6 yards over 1. I just put it like this because that's how you will typically see it. And then what are we wanting to find at the end? Feet. So for these, I can do that for each and every one of those. I see pounds is at the top, but I want to go to ounces. So I need to get rid of the pounds. So pounds go on the bottom so that those can cancel and ounces go on top. Gallons, I want to get rid of gallons and I'm trying to get to quarts. And then this one, we're getting rid of fluid ounces and we're trying to get to a cup. All right, now all that comes in is our memorization. So that's something that hopefully some of these, you know, we've gone through it the entire chapter. We've used these numbers as well as we made the note card in class. So I'm really hoping that helps you memorize, but sometimes you really do just have to memorize it. So as you're going through these, if you don't know any of these, like this one, how many ounces in a pound, that's tricky for a lot of students so far this year. So like put a star and then maybe the star means you need to really memorize the conversion factor there. But say we get here, how many feet are in a yard? 3 feet in 1 yard. So from there, we know these cancel. And then I like to circle what we're left with because that shows me, does this match up with this? If it does, I'm on the right track. And then we just multiply across. So 6 times 3 equals 18. So that would be our answer. And 6 yards there are 18 feet. All right, for this one, I need to know how many ounces are in 1 pound. 16 and 1. And the hard part with this is I can't tell you this. Like that's part of this chapter is memorizing these. And I have been gracious and have not made you memorize everything. So I picked out the ones that we need to know that will be the most common that you will use throughout your life. So take heart in that every adult should know that there are 16 ounces in a pound. If they don't, like, what's happening? But when you grocery shop, when you cook, when you do a lot of things in life, you will just need to know some of these things. So what we're asking you to memorize is not over the top, but it is helpful for you. So we cancel these out, the pounds cancel, and then we just multiply 3.25 times 16. And then this is where the math skills will come in. We have to make sure we're doing this correctly. 2 and 52, but is it 5,200? No, because we have 2 decimal places. So that means we need to move it over. So 52 ounces. So going to the back of the top of the video, how many ounces are in 3.25 pounds? 52 ounces. All right, this next one here, gallons to quarts. I already have it set up. I know that the gallons cancel. But I want to know how many quarts are in 1 gallon. Well, that's something that we needed to memorize, but there are 4 quarts in 1 gallon. So what do? We multiply across. 2 times 4 equals 8. So in 2 gallons, there are 8 quarts. And I know some of you could do this in your mind, but the whole purpose is not to know like, oh, good, you can do 2 times 4 in your mind. The purpose is unit analysis. Do we know how to set these up? Because these are maybe not too difficult, but once we get to rates back here, we're having to go from miles to hours to feet to seconds. So we're having to do a lot more. This is kind of, think of it as like the warm-up. Yay, these should be fun, the candy of the test or the chapter, however you want to look at it. All right, 40 fluid ounces, we want to go to cups. In 1 cup, there are 8. So we can cancel out the fluid ounces. Multiply across. It's always top and bottom. So far we've only had the top ones, but look, this is at the bottom. So that means what it leads us to is 40 divided by 8, which equals 5, because 8 times 5 is 40. So 5 cups. Hooray! All right, we'll do the same pattern as this. So what do we have? We have 0.6 km times in a line. Km goes at the bottom because I want to cancel that. I'm trying to get to meters, so that's why that goes at the top. How many meters are in a kilometer? 1,000. Kilo meaning 1,000. This you also just need to memorize. That's something I had to memorize too, if that makes you feel better. Multiply across. If we have multiplying by 1,000, we can just move the decimal however many zeros. 1, 2, 3. So we go 1, 2, 3. Fill in that. So 600 meters. All right, this one, we have 3,500 milligrams times in a line. Milligrams goes at the bottom. Why? Because we're canceling it because I want to get to grams. Grams goes at the top. In 1 gram, there are 1,000 milligrams. So milli also meaning 1,000, but we're dividing, it's getting smaller. So we can cancel these out. We're left with G. That's good. We want the grams. Multiply across, and we get 3,500 over 1,000. Easy way that you can do this, either you can just automatically move it over. So if we're dividing, we're going to the left, we're getting smaller. So we could go 1, 2, 3 and say it's 3.5 grams. Or I like to always go like that. It's just very fun for me to cross out the zeros because we're dividing by 10, divide by 10, or divide by 100, basically is what we're doing. Then we have 35 divided by 10, and then it's really easy. 1 0, we just move it over. So 3.5 grams. So you shouldn't have to like set up this elaborate 3,500 into 1,000, and then you'd go through all of that just to find that it's 3.5. Eventually, I don't know. So we need to do this method. We've got easier ways to do it to help you save on time. Because as a matter of fact, you might think that because we ask you to show work, we don't care, like we're making you take up so much time. But no, my mind always wants to save time. But as I've learned and continued on in math, I see you need to show your work in order to get to the right answer. So many of you can maybe do some of this in your mind now, but it's going to get harder and more advanced. And then you won't know how to do it in your mind, and you need to show your work to work it out to make sure you get to the right answer. All right, from there, milliliters. Milli means 1,000. And then 1, we cancel this out. We have 2.4 times 1,000. For timesing, multiplying, we're going to the right. How many? 1, 2, 3. So we have 1, 2, 3. So 2,400. 2,400. All right, last one on this page, 125 centimeters. That's what we're given. Times and a line. We're getting rid of centimeters. So centimeters goes at the bottom. What are we trying to find? We're trying to find meters. How many centimeters are in a meter? Centi means 100. 1, so we can cancel out the centimeters, multiply across, and we have 125 over 100. We can move the decimal from here over twice because of those 2 zeros, so we go 1 and 2, and we have 1.25 meters. All right, we finished the first page. Amazing, right? Hopefully, definitely pause, go back. I think just practicing this, even if you already have the work, go through it if you haven't shown unit analysis, and just go through actually doing the unit analysis, because come the test, I can't help you out with knowing how to set it up, because that's what this whole chapter has been about. I also can't memorize for you how many quarts are in a gallon. That's just something that I know you guys are so incredibly talented with your memory and just all the knowledge you have in your mind, and you guys are so bright. So I know you can do it. Be confident. You can. All right, we are on the second page. Now we're going from metric to customary, or vice versa. This is where I mentioned in class, I will be nice. Remember in the video just now, I said we will be gracious to you. Some of these, like these first two, you should just memorize. That will also be helpful in life. But some of these other ones you don't typically see too much. But let me tell you, if you're traveling to Europe or anywhere else in the world, then that will be helpful. It'll be helpful to know how to do this. So same thing we're doing, unit analysis. So we just have different conversions and different factors that we need to use. So let's start with what we have. 6 inches times in a line. Inches go at the bottom because we're getting rid of inches, and we want to go to centimeters. Then you ask yourself, how many centimeters are in an inch? 2.54. Then we can cancel out the inches. multiply across, and we have 2.54 times 6. And I need to move it over twice because there's 2 spots there. So 15.24 centimeters. All right, next one. 8 kg. And I think that's why I find these so fun, you guys, because you can do it kind of fast, especially when you have this and you're not like pulling it from your mind, but you need to know how to set up the unit analysis. So that's gonna be, as I've been mentioning, so important. And the reason I keep on mentioning it, you're probably so sick of hearing it, is because we've gone through this and so many students are still not using it. And I don't know why. I think it's because you have to show a lot of work, so I do kind of know why. But it can be very fun and satisfying. Fun in the fact that I know I can get to the right answer, so 17.6. If only you set it up. So 4 liters times and a line. We put liters at the bottom because that's what we're getting rid of. Quarts on the top, that's what we want. Let's look here. There are 1.06 quarts in 1 liter. All right, let's multiply. Times 4, 4.24 quarts. Interesting, right? I don't know when you need that, but we shall keep on going. 150 pounds is what we're given, times with a line. Pounds goes at the bottom. Kg goes on the top because we want to cancel out these. But we need to know that there are 2.2 pounds in 1 kg. So this brings us to 150 divided by 2.2. Then we have to know that the top number goes inside the house. So we have 2.2, 150. But can the decimal be on the outside here? No, it cannot. So we need to move this over, which means we need to move this over. So we're doing 22 into 1500. So then we need to start. Well, I know the answer, so you would just eventually have to go throughout it, but let's see. 6 times 22. 12 plus 1 is 132. You have 180. Should be times 8. So this is just like any long division. You just have to go through a bunch of the numbers, but to save time, that is why I am looking at my own work of what the answer is so that we can just keep on going through this as we go. And then maybe I did this wrong. Let's see. 176 0. I have in my notes that it's supposed to be 2, but I think that is wrong. Because 2 times that would be 44, and that's too big. So maybe it's 1. We'll just see. Maybe I round it as it goes. It looks like it will just always be repeating. Because I just had it here. Oh, it's an 8, and then that repeats 176. So I rounded up, that's why. Figured it out. And then, because this would just repeat 8, 8, 8, 8, 8 going on. Well, the line should really be there. So we just round up 68.2. But the good thing is if you show all this work, even if you put 68.18, I can see that you did the work, you did the unit analysis, and then we got to where we needed to be. All right, 3 miles. So in my opinion, that was the hardest part. This was the hardest part right there. But I actually set it up so I knew what I needed to do. So that part was fun. Like this part, so 1 mile, there's 1.61 km, multiply across. 1.61 times 3, 384, so 4.83. All right, let us continue on. Now we have rates, converting rates that we have. And this is where it becomes a little more, we have to do a little more. Easiest way to say it. But look, we're almost done. So these will take you longer. So it may be like, oh, look, we don't have as many problems on this test. Yay. But these will take a bit longer, and they need you to really use your brain and mind, which it should, it's amazing. It should be very fun for you. So same thing. Let's start with what we have. We have 3 miles over 1 hour. So it doesn't say 1 hour, but it's assumed, and it's just known. It's a known that it's 1. So let's do the first thing is I need to go and look at, these are 2 different things. So miles to hour need to go feet to second. They don't match up, which means automatically I know I have to do 2 different conversions in order to get to where I need to be. So I like to start with getting rid of the top one. So same thing, if we don't imagine this, that scares you, don't write that yet. But same thing as we've done all throughout here. And I'm going from miles to feet. So how many feet are in 1 mile? This is something you have to memorize that we've gone over and reviewed as well, 5280 feet in 1 mile. What that tells me now is I've gotten rid of the miles and I've ended up with feet. Feet is part of what I need to end with. So amazing, hooray, huzzah. Okay, but that doesn't get rid of hour because I need to go from hour to seconds. So if hour's at the bottom, it means I need hours at the top so that they can cancel. And what am I trying to get to? Seconds. So what you could work out, usually it's only because we've done this so many times that I've just memorized there's 3,600 seconds in 1 hour. But if you didn't know that, you could actually do how many minutes are in an hour and then how many seconds are in a minute. But you would still get to 3,600 at the bottom. So cancel out that, we're left with seconds. This is what we need. So we have seconds and feet. So multiply now across. And we have 3 times 5280 over 3600. I know automatically we can take that down 1. So that's fun. And then from there, I know 3 can go into 360. Well, 3 times 12 is 36, so add a 0. So that would be 120. So right now I'm just reducing it, so I have less work to do. I know 2 can go into both of these, so that could get that down to 60. And I don't know from the top of my mind what that number is, but we can do it pretty fast. 1, 6, and 4. So 264 is what it gets it down to. So then I have 264 divided by 60. 60 goes on the outside. 264 on the inside. We'll try 4. This is 4 times 60 would be 240. And then we have 6 minus 4 is 2, 4, and 0, which would be 240. That gets us to 0. Amazing. So 4.4 feet per second is our answer. Next one, 16 ounces in a week. So start off with what we have. 16 ounces over 1 week times in a line. And then we can confirm these are both different. So ounces to pounds and week to year. That needs to happen. So automatically I know I'm going to have to do at least 2 conversion factors within this unit analysis. From there, I like to get rid of the ounces, the one on top. So ounces, and we're going to pounds. You have to know, which we use this on the first page, I believe, there are 16 ounces in 1 pound. So that will get rid of the ounces and leave me with pounds. That's in the final answer of what I need. And then I still need to get rid of weeks and go to year. So if week is at the bottom, I need to put it at the top so that I can cancel it out. And there are 52 weeks in 1 year. Something else you will need to memorize, but hopefully isn't something new because all throughout school, hopefully you've been talking about that. All right, bringing it over here, we have 16 times 52 over 16. The 16s can cancel themselves out, and we're left with 52. So we would have 52 pounds a year. Continuing on, let's start with what we have. We have 1.5 meters over 1 second. And then let's see, we're going meters to kilometers and seconds to hours. So yet again, I need at least 2 to get these going. Then from there, let's see. Let's get rid of the meters, and we're going to kilometers. And kilo means 1,000, so I know there are 1,000 meters in 1 kilometer. So that's what I have to start with. That will get rid of the meters there. And then we have km, so that's something I need at the bottom here. And then we need to go from seconds to hours. So seconds needs to go on top. Why? Because I want to cancel these. So they need to be one on the top, one on the bottom in order to cancel. And we're going to hours, so that will go at the bottom. How many seconds are in an hour? 3600 seconds in 1 hour. This one too, if you didn't know, you could go, maybe I'll just write it out. No, oh yes, okay, I'll write it out. So if you didn't know, another way of doing this, so we have 1.5 meters over 1 second. We just finished the 1 km over 1,000 meters. But then say we didn't know this 3,600 seconds in an hour. What I would do is how many seconds are in a minute, because I know there are 60 seconds in 1 minute. So that gets rid of that. But then I need to get rid of minute and get to hour. And there are 60 minutes in 1 hour. So then that cancels out the minutes. Then we have 60 times 60, which is 360. So 3600. So that's another way, same as up above here, wherever we did that before, number 17. So from here, we just multiply across. So we get 1.5 times 3600 over 1,000. Go ahead and divide, get rid of those zeros. And then from there, what did I do? You can just, well, let's see. If I want to make this easier for myself, so you could just do 1.5 times 36 and then divide by 10. But if I want to save time, remember, I want to save time, then I should be able to divide by 10 and move this over to this one. So I would be doing 0.15 times 36. Let's see. It should work. 0, 3, 6, 9, 0, 4. Let's bring this down. 540, but I have a 0.15, so bring it over 2, and 5.4. Yep, that is correct. So that's a trick to save time. If that does not make sense to you, that's fine. Just do 1.5 times 36. You get an answer, and then divide that by 10. So your answer should be 54, and then divide by 10 would move it over to 5.4. All right, last one for this one. If my phone won't die from lack of memory, not die, but run out of memory over 1 minute. So that's what we have. Quarts to gallons and minutes to hours. So we need at least 2 of these. All right, get rid of quarts first is my preference, going to gallons. And then we know there are 4 quarts in 1 gallon. That gets rid of that. We have gallons, that's what we need. Now minutes. How many minutes are in an hour? We have 60 minutes in 1 hour. So that gets rid of the minutes and leaves us with hour. Gallons an hour, that's what we want. Multiply across. We have 2 times 60 divided by 4. 60 divided by 2 is 30. So the math, you can take your time, do 2 times 60, which equals 120 divided by 4, also will be 30. But this will probably be of the more difficult side because you need to do unit analysis. You must, like there's no other way I think that you could do that. And then we'll go into these, which are more word problems and using your mind. Okay, last part, and let me rephrase. It's not that you haven't been using your mind, but this is a different part that, comes with word problems that seem a little bit maybe intimidating for some students, but never fear, we will work through this together. So 21 says a rope measures 9 feet and 8 inches and another measures 7 feet and 11. What is the total length? So we can just set that up over itself, 7 and 11. That gets us 16. 8 plus 11 is 19. But we have feet and inches there. We can't just say 19 inches because there's a foot within there. So what do we know is that there are 12 inches in 1 foot. So it's 12 inches plus 7 plus 12 equals 19. So we could do 19 minus 12. So that becomes 1 foot that we need to add there. And then this becomes our inches. So 16 plus 1 would be 17 feet. And then we have the inches here, which would be 7 inches. So I think that one is pretty fun. Basically add it up, and then if it has spilled over, 12? Like if it was 16 feet and 12 inches, you would just say that's 17 feet. If it was 16 feet and 13 inches, that would be 17 feet and 1 inch, because we want to put as many feet, like consolidate, put as many feet as we can in the feet jar, the feet jar, the foot jar, I don't know, however you want to call it, and then keep the inches as they are. All right, next one. A rectangular yard measures 15 yards by 20 yards. How many feet of fencing are needed to surround the entire yard? If it is easiest for you, let's just draw the yard. So we have 15 and 20. And we want to know how many feet of fencing are needed around the entire yard. That's why I drew, because we are not looking for area, which would be 15 times 20. We're looking for the perimeter. So perimeter means we need to add all the sides. So 20 plus 20 is 40. 15 plus 15 is 30. So that means there are 70 yards needed. That's not our answer though, because it says how many feet of fencing are needed to surround the entire yard. But if we know that 70 yards are needed, that is what we start with. And then guess what? We've got unit analysis. We want to get rid of yards, so they'll get the bottom. And then we want to keep feet. How many feet are in 1 yard? 3 feet in 1 yard. So the yards cancel out. We're left with feet, which is what we want. We multiply across. 70 times 3 is 210. So 210 feet are needed to surround the entire yard. Amazing! All right, last page we have here. A 3-liter bottle contains juice. If you pour 200 milliliters per glass, how many full glasses can you pour? I have no idea, you guys. Just as you probably also have no idea. Like, how are we supposed to know that? Well, let me tell you. Let's figure out how many milliliters are in this 3-liter bottle, because we want to pour out 200. So I can't go 200, 3 divided by 200 to figure it out, because these are two different units. So first thing I need to do is start with what we're given. And what do we want to end with? We want to end in milliliters so that we can then do the math that we need to do. So start with what we have, 3 liters times and a line. It's a unit analysis. We want to get rid of the liters and go to milliliters. Milli means 1,000. So that gets rid of the liters, leaves us with this, multiply across. 3 times 1,000 equals 3,000 milliliters. Okay, this gets us closer to knowing, okay, what can we do with this? So instead we could say a 3,000 milliliter bottle contains juice. If you pour 200 milliliters per glass, how many full glasses can you do? Well, we have 3,000 and we want to see if we do 200, what would that be? Here we can cross out the zeros. 30 divided by 2 equals 15. So how many full glasses? We could pour 15 glasses, full glasses. All right, last one here. A runner completes 8 kilometers in 40 minutes. So let's just start with that. Start with what we're given, because even for myself, this one is a bit trickier. So that's the nice thing to know, is that even for teachers, sometimes it makes us think. Even for adults, if you ask your parents this, they'd be like, I don't know. But you can tell them, I do know, because that's what we've been learning. And this is just a next step of how you'd see it maybe in the real world, but we're still setting things up. We still start with what we're given, 8 kilometers in 40 minutes. Amazing. Now we want to know, what is the runner speed in kilometers per hour? So we don't need to mess with kilometers here, because we have it in the end. So it's here and it's here. So don't even mess with this one. That will be confusing, because remember, I always say I like to start with the one on the top and get rid of that. But what if we don't need to get rid of it? If we don't need to get rid of it, just don't even think of it. Don't even look at it. Because what we're really wanting to do is get rid of minutes, because we want to go from minutes to hours. So if we want to get rid of minutes, we have to put minutes on the top, and we want to stay with hours. So hours go on the bottom. How many minutes are in an hour? 60. So that's what we're then now figuring out is we have, let's cancel what we have. And now we have kilometers at the top and we have hours at the bottom. That's what we're looking for, kilometers an hour. Once we get it here, multiply across. So we have 8 times 60 over 40. As usual, what do I like to do? Cross out the zeros because we're dividing both sides, top and bottom, by 10. Then from here, 4 and 8, those can go into each other. I know that 4 divided by 4 is 1. How about 8 divided by 4 is 2? Now I'm left with 2 times 6. What is 2 times 6? It's 12. So 12 kilometers per hour. So when I look at this and I see that as the answer, I don't really get it, to be honest. But when I look at the work I've done, I see that, oh, okay, I start with what I'm given. So that should be a given for this whole entire practice test, for this whole chapter. Always start with what you are given. We're given 8 kilometers and 40 minutes. Then we know we're going to have to change it. So just do the times and a line. Then the question becomes, what do I actually have to change? So kilometers and kilometers, those are the same. That means I don't need to change anything. But how about this? Minutes to hours, those are different units, which means I need to change them. So that's why we only did one, and we only worried about this one because this could stay, but this could not stay. And we put minutes on the top because to cancel the units, they have to be on one on the bottom and one at the top. The numerator, the denominator. And then we have hours and kilometers as they need to be. You just multiply across. If you didn't want to do all of this, you would just do 8 times 60, which would be 480. And then it would be 480 divided by 40. I would still just cross that out and then do the math. But if you needed to, it would be like this. 480 could go in there once. 40 into 80 twice. And you would still get 12. All right, so that's it. The main things you need to know, which I gave a really long intro in this video, but you need to show the unit analysis. That's what this whole chapter is about. It's not about, can you just get to the right answer? Of course, in school, that's how you get graded, is by the answer, but also in math by the work that you show. So if you're not showing any of this and you just put this and you get it wrong, which I can almost guarantee, I mean, you can never guarantee everything, but it's going to be very hard for someone to get all of these right, especially as we get to this second page and all of this, if you're not showing the unit analysis. So it's not even about, oh, Mr. White just wants us to show work, as does the whole school. The whole math department is going to be on you about showing work, but particularly with unit analysis, you have to show your work. It will help you out so much. It will become your best friend because, as I mentioned, I wouldn't know how to do any of this. Like if I worked in this every single day and just did this for days on end, I would just imagine this in my mind and then I could maybe do the mental math. But even then, no. Why would I do that? Because we can just show our work and write it out. So be encouraged. Go back through this video if anything didn't make sense. You can go through problems in your book, even redo the homework if that is helpful to get more practice problems in, but just as a way to really see and practice this method, because that's going to be what will bring you towards success in this chapter, as well as for the rest of your math and sciences. So I'll see you in class.